Now let's learn the fundamental theorems of calculus. These are the theorems that connect the integral to the derivative. Let's start with the first fundamental theorem. So to begin with, we'll define a function y of x, which is an integral from a to an upper limit x, which is now our variable. And we'll use the dummy variable s so that we don't get confused with using x. So we're going to look at this function. So that it varies with the upper limit. If we take the derivative of this function and use the definition of the derivative, we have y prime of x is equal to the limit as h goes to 0 of the integral from a to x plus h of f of s ds minus the integral from a to x of f of s ds, all divided by h. So what is the difference here? The difference between an integral from a to x plus h and an integral from a to x. We can draw a graph to make it apparent. So if we have some function here, we have a, we have x, and we have x plus h. So if we're looking at the integral from a to x plus h, so the area under the curve from a to x plus h, minus the area under the curve from a to x, we just get the area under the curve from x to x plus h. So this becomes the limit as h goes to 0, the integral from x to x plus h of f of s ds divided by h. Okay, so now we're just talking about this area here. This has width h, but h will become an infinitesimal because we're sending h to 0. So that means we're basically only looking at the width here of h, a rectangle where the width is h, and the height then is our f of x. So the area of that rectangle is h times f of x. So this is well approximated by the limit as h goes to 0. The area of the rectangle, h times f of x, divided by h. The h cancels, so then we can take the limit, and that's equal to f of x. That's the fundamental theorem. So let's write that another way. We can write that as d dx of the integral from a to x of f of s ds equals f of x. The first fundamental theorem of calculus. So let me summarize this. To derive the first fundamental theorem, we look at an integral which has a variable upper limit. So we define a function y of x, which is the integral from a to x of f of s ds. We take the derivative using the definition of the derivative. That gives us this small area here, which reduces to a single rectangle, and we get f of x. So the beauty of the fundamental theorem is that now we have a connection between an integral and a derivative. In the second fundamental theorem of calculus, we'll exploit that connection in order to learn how to integrate functions. I'm Jeff Chasnoff. Thanks for watching, and I'll see you in the next video.